So welcome everyone. My name is Pratik Agarwal from Ivy Professional School. Thank you for attending this part two of our introduction to SQL series of webinars. Last weekend I had done one small introduction on a quick introduction on SQL. Just to quickly recap what all we had done last weekend. Last weekend excuse me, last weekend we had discussed about some of the basic SQL structure and what are the different SQL statements which are available and how do we work with different SQL statements. We had done some basic SQL queries as well on MS Access using a sample database, which was a student database, which had various fields like these fields that you can see here. Some of the queries that we had done last weekend was from student where MTest greater than 90, select full name MTest. And we had also discussed about execution sequence. We had discussed that from is always the first thing that gets executed and select gets executed towards the end. And everything in between comes sequentially or executed, they get executed sequentially. So from student, that means the table will open. From that table, all the rows which are meeting this condition, which is MTest greater than 90, they would be selected. And for those selected rows which are meeting this condition, the query would display the full name as well as the MTest column information. We had also discussed about this ptest plus mtest divided by 2 from student. What it means is in this query there is no condition. That means all the rows of the table are eligible for this query. So in this query, what's going to happen is that this query is going to show you the average of p-test, physics test, and mathematics test, right? I think there are a couple of questions. Let me see if there are any questions that are asked. All right, thank you everyone. All right, so that's what we had discussed last week, and plus also we had discussed a couple of things like, say for example, if you want to create a column, if you want to assign a column name to some expression, say for example, SID is obviously part of the column, part of the table. Full name is also part of the table, but MTest plus PTest divided by 2, which was average, which was not part of the table. So what we are doing here is as AVG, that means that expression's output would come under this column called as AVG, which was originally not part of the table, but just for displaying it would come under AVG column here, right? Or these were some of the things that we had discussed yesterday. Last weekend. Weekend in today's session would be roughly this. We will talk about how to handle different data types in SQL, some of the very commonly used functions in SQL, and we'll talk about comparison and pattern matching operators in SQL. If time permits, I'm going to talk about grouping, sorting, and text functions as well. The sample database that I'm going to use is on Access. This is the sample table that we were using. Student table with these fields: ID, full name, date, class, H code, which is house code, red, blue, green, yellow. D code, which is district code. Remission is the fact whether or not a person has paid the fees. M test, mathematics test, and T test, physics test. So these are the columns that we have in our student table, which will be the primary table that we'll use. We might use some other tables as well, depending on the kind of query that we are doing. All right, so let's do some practice queries. I'm going to explain you some of the practice queries. You see, we had discussed about these steps in the last webinar. I had told you, right, that the first step while you're writing the SQL statement is first to visualize the final report. So kind of, in your mind, if it is a complex query, I always recommend this in your mind. Create a final picture, what kind of columns you want to display in the report after running this query. So that would help you to figure out what kind of columns you want in your SQL query. Okay, so it really helps to write the query faster with lesser errors. Think of the execution sequence. So suppose if you're looking for people who have scored more than, or students who have scored more than 80 in mathematics test, think of the execution sequence. So ask yourself, which table am I going to get this information from? So obviously, if I'm to write this query, I would get this information from student table. So the from student where, and the condition here is where MTest is greater than 90, and what do I want to display? Probably their full name and their mathematics test score. So select full name comma MTest. So think of the execution sequence like that. Then write the SQL statement. Okay, SQL is not case sensitive, But SQL is definitely spelling sensitive. If you make a spelling error, it cannot rectify by itself. You cannot write more than one SQL statement in one window in Access. What it means in other databases, this is not. So suppose if I go to the SQL, if I create a query object, create sorry, not query wizard, create query design. I'm closing the show table option because I don't want to create the SQL query in design view, but I want to go to the SQL view. So this is the SQL view of the query object. And once I'm here, I'm writing select. As I said, you can't write more than one SQL statement in one. So what I mean by that is, if I have written select star from student, which will basically, if I run this query, I'll get all the fields since there was no condition. So that means all the rows as well. So the entire table is shown as it is. So if I go back, right click on the query object in SQL view. Now, what I mean here is that you cannot write one more SQL statement here. So if you write two SQL statement in the one query object in it won't run. It will give you syntax error. Some other databases, you do have that flexibility. So that's what it means. You can't write more than one SQL statement in window. A function in SQL looks pretty much similar to the functions that we have seen in Excel. Okay, that means there will be a function name, there will be opening and closing parentheses. Most of the functions will accept some arguments, some parameters on which it will compute and return you some value. Okay, so say for example round function, round 8.89 comma 1. Here if you look at the object of this function, the object of this function is to round this number up to one decimal place, and that is where the result would come out as 8.9. So if you look at this function here, this function is accepting how many parameters? This function is accepting two parameters. The first parameter is the number that we want to round, and the second parameter is is up to what decimal place do we want to round this number to, right? So this function is designed, round function is designed to accept two parameters, right? Similarly, there are so many different functions, and all of them have different set of parameters that they can accept, all right? And then there could be certain functions. Say, for example, there is a function in SQL called as date. What date function does is it gives you current system date. Current sys date. Today you have in Excel, you have date here in SQL. Okay, so but this date function doesn't accept any parameter. So what I'm trying to tell you is that there will be some functions which would accept parameters, and there will be some functions which may not accept parameters depending on the type of the function. Remember, a function will always have a pair of bracket as suffix. Now, when you're working with different data types, that means different data type values in SQL, you have to handle them differently. You see, when in our SQL statement, when I was writing where m greater than 90, this 90 is an integer value. That means a number value. A number value is handled without any quotes or without any special character. Whereas if my condition was where sex is equal to female, that means F. Since F is a character value, we have put F inside a pair of double quotes. Okay, and if you don't do it, then it will throw an error. Okay, so that is why a text value is handled with a pair of double quotes. Access SQL allows you to work with single pair of single quotes as well, but most of the databases allows you to work with pair of double quotes. So if you want to be safer, use double quotes. Date values are handled with a pair of hash. Say for example, DOB is equal to hash of 01/12/2008 hash, right? Or 2 pound symbol. A boolean yes no value is handled without any quotes. It can be compared. Say for example, remission field that we had in our student table can be compared with remission is equal to no, or remission is equal to yes, or remission is equal to 1, or remission is equal to 0, or remission is equal to true, or remission is equal to false. But here, the point that you need to note here is that we do not want to use these quotes or double or pair or double quotes, because this no or this yes or this true or this false, these are not text values. These are system boolean values, and hence we are not going to use any quotes or double quotes, pair of quotes or hash or any special character to handle them. Okay, so they can be directly compared with yes no without any quotes. And please note, this is a very common error people commit. Do not address column name, for example, full name or student ID or DOB, date of birth, or H code, which is house code, or D code, which is district code, with any special or uh, or special hash or any special character for that matter. The field name would never be handled with any special character, but the values of the fields, if used in SQL, would have to be put into the right pair of special characters depending on the type of the data that you're working with. Okay, so this is a very important note to keep in mind. Now, let's do some of these questions, some of these examples, and it will be a little more clear. So we have done a couple of them. Say, for example, list the female students who have scored less than 92 in maths. So last time we had done people who have scored more than 90 in maths. Now let's do this first. Female students who have scored less than 92 in maths. My database. I'm going to start with. So from which table am I going to get this information from? From the student table. Query says the female students who have 92 in math. What are the fields that I want to show? I want to, I want to put the condition on gender field, sex, and I also want to put the condition on MTest field. So these are the two primary fields that I want to put the condition against. So I'm going to use them with where sex is equal to F for female and why, and because there are two conditions which needs to be true in order to solve this query, and MTest value should be less than 92. Now, since F was a text value and hence we have put it under pair of double quotes, 92 was an integer value or number value, so we have not put it under the special characters. Now, while selecting, that means while displaying, what are the things that you want to display? Probably, it is completely up to you, but what makes sense here is full name, probably the gender here, and the mathematics test code, right? Now I'm going to run this query, I'm going to do design and I'm going to run this query. When I run this query, then there is only one female here which is meeting that condition, right? Or one record here that condition that we want. Female students who have scored less than 92 in math. So we have got only one student who scored, one female student who scored less than 92 in maths. List the students who are born before 01/01/2000. Date of birth here, right? So again, I'm going to, if I want, I can save this query stating whatever name I want to give, right? Always give some meaningful name. Say query one, female with uh, low math score, something like this. When you store it, when you save it like this, then it comes under here in the Explorer tab, in the Navigation tab. So I'm going to create another query object. Select from which table, from student table, and then students who are born before 1st of January 2000. So where DOB is less than, since it's a date value, so we'll use a pair of hash, pair of pounds, symbol 01/01/2000, close the pound symbol here, and we want to display full name, probably date of birth, right? These are the students who are born before 1st January 2000. Okay, so that's how it is showing. Go to the SQL view. Now list the students who have not paid their fees. That means here we're going to use a boolean. In our student table is, or the fees field in our student table is remission, which means if someone has paid the fees, then the value would be yes, or it would be tick mark. If someone has not paid the fees, then the value would be blank here, right? So I'm going to overwrite on this same query. select from student, what is the condition where remission is equal to false. Okay, this is one way of writing it. Select, and while selecting, probably I'll select full name and remission value, and then I'm going to run this query. Run this query, and these are the students who have not paid their fees. The same query, I could have written the condition like this as well. Remission was going to do 0. Even that would have worked. Okay, or I could have written here something like this, where not remission, not remission. So that also means that uh, the false of remission. Okay, so this is how you handle Boolean values in your SQL query. Now, question number 4: list the students who come from district YMT. Right, looking for students specifically who are coming from district YMT. I'm going to rewrite the overwrite on the same query. Select from students where, what is that field? Decode for the district from YMT. So YMT being a text value, that is I'm putting them under pair of double quotes. Full name, decode. These are the students who are coming from YMT. Now, I'm going to add one to this the same query. Suppose if the question is select the students, select the sorry, not students, select the distinct list of districts from where the students are coming to the school. Suppose that this is the query. Then, if this is the question, then what will be the SQL query? Now here, if I write select where the students are coming from. So if I write select decode, obviously there is no condition here. I'm going to get rid of this question. Select decode from student. Now if I were to write this query and run this, then it will display me all the districts from where the students are coming. But you will see that there are repetitions because obviously there could be multiple students coming from the same district. So hence there would be repetitions if you run this query as it is. However, suppose you don't care about it. Suppose you are planning for bus routes. You want to plan out for your bus routes, and you just want to see the distinct list of districts from where the students are coming, because even if one student is coming from that district, you want to send the bus there. So then in that case, you do not want repetition. So what you can do here is you can put one more clause called as distinct. Select distinct decode from student. So select distinct decode from student. So now it is showing you the distinct list of decode or distinct list of districts from where the students are coming, right? So that's how you use distinct. Now, at times people may get confused. Suppose what if I added full name as well? Then what would happen is, it's not an error, but what would happen is now it is looking for this combination, distinct combination of decode and full name. No longer is it looking for only distinct decode, but it's now looking for distinct combination of decode and full name. So if it so happens that there are multiple students having the same name coming from the same district, then they would be shown only once. That combination would be shown only once because that's what distinct does. So it's now looking for distinct combination of decode and full name. You cannot put distinct in between because that doesn't make sense. It will give you a syntax error. It doesn't even make sense. So distinct has to come just after select before the fields. Okay, so that's how distinct queries work, and it's a very simple operator but very useful. The next question is find the age of students. So how do we find the age? The hint says use date function. So if we want to find anyone's age, how do we find it? So basically, if you know someone's date of birth, so what you do is you say that okay, whatever the today's date is, minus that date of birth. So today's date we will get from date. So then the main condition here would be date minus DOB. This will give us age in days, right? And if we divide this age in days by 360, we will get age in years. Okay, so that's the approach that we want to follow here. So again, I'm going to rewrite, overwrite on the same query. Select from student where, uh, no, there is no where, because we just have to find the age. So we want to write full name and date function minus DOB. Suppose if I just write this much, so it is giving me the name of the students and it is giving me these numbers which are in tens of thousands, right? The reason why they are coming in tens of thousands, because these are the number of days someone has lived. Okay, so basically date, which is today's date, which is current system date, minus date of birth, giving the age in days. If I were to divide this entire thing, right, by 365, I would get the age in years. But obviously, it's coming as fractional value because we have divided it by 365. Now, if you want to round it up to 0 decimal place, is a perfect time, perfect opportunity to use the round function, round off this entire expression's output up to comma 0 decimal place, right? So now this age looks like age, okay? It doesn't look like anything else. Now, obviously, if you notice here, the column headers show that EXPR1001 expression, some random name which has been assigned to this. Because why? Because we have not, there is no field called as age in the table, right? So what we can do is we can create an alias here, just a column label here called as age. So now it shows under this column called as age. So again, it's not with select, we are not modifying the table. We just in the output we are just modifying the data output. Let's look at some more examples here. Find the average score of mathematics and physics subjects for all the students. Find the average score of mathematics and physics subjects for all the students. So it's a very easy query here. Again, there are no conditions. So, the way I'm going to write this question is from student, select full name, and then p test plus m test divided by 2 ABG. This is showing you the average of both the subjects for all the students. List the students who are playing a musical instrument. Now here we are going to use a very simple intersection clause, okay, which is called as in. Okay, now how do we use it? Go back to my explain you this concept. It's a very simple concept. So, say for example, if these are the two sets, set 1 and set 2, and if you want to find the intersection of these two sets, so intersection between these set 1 and set 2, the elements which are common. So, what are the elements which are common? 3, 8, and 10 are the common elements. So, that is intersection. The same thing can be simulated in SQL using in operator. So, from student where ID in 1 comma 3 comma 5 comma 8. So what this means is from the student table, whichever IDs fall in this set, that means the IDs which are common with this set, those students would be selected. I mean, students with IDs common in this set would be selected, and for them we are displaying the full name. So that's how we're finding intersection. Intersection between the set of IDs and set of given IDs here 1358. Okay, the same thing could have been without in. If you wanted to do it, you could have done it without using in, but with multiple OR statements. You have to write 4 OR statements from student where ID is equal to 1 or ID is equal to 3 or ID is equal to 5 or ID is equal to 8. So in does exactly the same thing which a multiple OR statement would do, but it has more power, especially when you're working with multiple SQL queries, which we'll discuss in just a bit's time. Opposite of in is not in, which helps us to find the difference in a set. So from student where ID not in 1358 means that all the students whose IDs do not fall in this set, right? But the real power of in comes into the picture when you are working with multiple queries. That means query inside query or queries, right? Say for example, you've got two tables. One table is called as books table and the second table is called as publisher table. The common column between the books table and publisher table is pub ID and PID. So in the books table it is called as PID and the publisher table is called the pub ID. So this is the common column which is linking the two tables, which is the foreign key between the two tables, right? Now if you want to know the publisher details of all the of the publisher who published book Babylon, and say for example in the books table we just have PID, but all the other publisher details like publisher name, address, phone number, email address, all other details are in the publisher table, right? So what we're going to do is look at this inner query right now. Okay, so from books where title is going to Babylon, and we are selecting PID. Select PID from books where title is going to Babylon. So if you just look at this inner query, what this will do is it will give us the PID associated with the book Babylon, right? Now once we have that PID, then we are saying from publisher table where pub ID in select PID, right? So what is happening here is that now from the publisher table we are only selecting those pub IDs which are matching with the PIDs in the books table which are associated with Babylon book, right? So now using in, we are able to find the intersection set of elements across two different tables using two different select queries, right? So this is called as nesting the query, writing one query another inside another query, right? So this inner query is a subquery and this outer query is an outer query, right? So the way it's going to execute is from publisher. So that means the publisher table will open, then it will go to where pub ID in. Then it sees that okay, there is one more subquery. Then the entire subquery will get executed. That means this inner query will get executed, and if the inner query gets executed, it will be replaced with the PIDs associated with which book? Babylon book, right? Now, if Babylon is a generic title, book title, and if there are multiple PIDs associated with them, so all of them would be selected, right? So then it becomes very, very similar query to this query that we had done from student where ID in 1358. Okay, so very similar query to that then. Okay, so that's the power of in. Okay, it really helps us to find the common elements between two different sets or two different tables using two different select queries as well. Okay, so let's do some exercise we had seen here. List the students who are playing a musical instrument. Now, obviously, in the students table, we do not have any musical instrument information. So, where is this musical instrument information? So, I'm going to go back to our database here. See, here there is a table called as music. If I open this table, what I see is there are two columns here. First is the student ID column, and the second is the type of musical instrument a student is playing. This ID column is not, the ID column which is associated with the type of instrument, but this is the student ID column. So that means that between the student table and the music table, what is the common column? ID is the common column, which is the student ID, right? So it means that these 1 through 9 students are playing these types of musical instrument, right? And if the question that was there, list the students who are playing a musical instrument, right? So it doesn't really matter what musical instrument, but he should be playing that student should be playing at least one musical instrument. So I'm going to again override this query. Select from student where ID in, again one more, select ID from music, because see this inner query or the subquery will give us all the IDs or all the student IDs which are there in the music table. If a student ID is there in the music table, that means that student is playing a musical instrument, right? And so if you're comparing that set of IDs from the music table with the outer IDs, so whatever IDs which are common, whatever student IDs which are common between student table and the music table would be selected, right? And now if I want to display their ID and full name, then I can do that. I'm going to run this query. So these are the 9 student IDs and their names, okay, of the students who are playing some musical instrument. These are the students who are playing at least one musical instrument, right? That's how we used in, right? Now, say for example, just for example, if you were to find these students who are not playing musical instrument, the only difference here we would have done was this. So from student where ID not in select ID from music. So this would display students who are, so these are the three students who are not playing any music instrument because their IDs are not listed in the music table, right? So that's how you use in and not in. In to find intersection, not in to find the difference between two different tables, right? Very helpful queries. List the students with an A as the second letter in their name. Now see what is happening here is we're trying to compare a pattern, right? What is the pattern that A should appear as the second letter in the name, right? Now if I were to write an equal to here, right, full name equal to something A, then it wouldn't have worked because then full name is exact matches, so it would have matched exactly that string, right? So we cannot use full name, we cannot use equal to as an operator here, but we need to use some other operator, and that some other operator is called as like. So back to my Excel document here. So equal to is called as exact matcher, and like is called as pattern matcher. Okay, and we also have not like, which is opposite of like, right? Now look at and you see this like pattern matcher operator is used with wildcard operators. Okay, these wildcard operators have some special power, especially when they're used with like. Say for example, look at this query from student where S name like S star. Now what is this star? Okay, now star is a wildcard operator which can be replaced with any length alphanumeric string. So an alphanumeric string of any length is what this star or asterisk mark can be replaced with if used along with like. Okay. Similarly, we have other wildcard operators called as question mark, which can be replaced with only one character, including alphabets, special characters, numbers, but only one character. Okay. Star can be replaced or asterisk can be replaced with any length alphanumeric string, and question mark can be replaced with any one alphanumeric or special character. Hash can be replaced with a single digit between 0 and 9. A to F under square brackets means any one character between this range. So any one character between A and F, inclusive of A and F. Any one character. So it could be replaced with an A or a B or a C or a D or an E or an F. Okay, but any one of these characters, I could have written, instead of writing A hyphen F, which means it's a range complete A to A, B, C, D, E, F, instead of doing so, if I had specific characters that I wanted to compare, then I could have written A under square brackets A comma E comma C and D. What it means is that the first character of the string should be A, the third character of the string should be D, and the second character or the middle character of the string should be one of these A, C, right? So this square bracket can be replaced with only one character within the range that is given inside the square brackets. And if you put an exclamation mark before inside the square bracket before the characters, then it becomes not. So that means if I were to say square brackets not AF, A to F, that means any one character but not between A and F. Okay. Excuse me. So look at this. From student where S name like A question mark BFG hash. So the length of this string that we are trying to compare is 3. The first character is A. The last character is a digit between 0 and 9. And the second character, the middle character is anything but B, F or G. Okay. So that's what this means. Okay. So remember, you cannot use like and equal to both together. You have to decide if it is a pattern matching you are doing, then you have to use like with its own set of wildcard operators. If it is an exact match you are doing, then you have to use equal to. Okay. So list the students with an A as the second letter. Go to the database. So select from student, right? What is the condition? Where full name like A as the second letter. right? A is the second letter. That means the first letter can be anything, but only first letter. So that means I'm going to use a question mark here because we just want to replace with only one character. Question mark and then A, and then it could be anything. So hence question mark A star. Okay, which means first character could be second character has to be an A, and after that there could be any string. Is there a question on the?
Yeah, Pratik, Shomo here.
Yeah,
Uh,
Shuman, tell me.
just a few days back, actually I'm working in Teradata SQL. So
Okay,
I need to create one query where I have to filter some brands. So brand
okay,
names are there. So I used not like and like option to filter brands.
okay,
But my supervisor told me that it is better to use some flag for each brand and later use not in or in statement instead of like statement, because sometimes it will not select all records. So means just wanted to know what is the difference between not in or not like and in or like statement if I am using for some string or some values like
okay, okay, okay.
string
So
values.
very two concepts. So Shuman's question is, what is the difference between not in and not like, right? So huge difference. So first, understand not in or not in is used for comparing. I mean to find difference between two different sets, right? Whereas when the moment we say not like, right, then what we are trying to do here is that within a particular string, that means within one value. Say for example, full name not like this. That means we are looking for all the full names which do not have A in the second letter. A is the second letter, right?
Yeah, right. Yeah.
Whereas if we were to write not in full name, not in, right? So I mean, it would have had a very different context, I mean, to use it because then you see, so I have not seen your table, okay? So it could be a little difficult to comment on it, but normally we don't really compare not in with not like because the purposes are very different, right? Say for example, you already have a list of brands created in another table, only list of brands, right? And you have created some kind of flag, as you said, right? Some kind of
Yeah.
flag means some brands are high premium brands and some brand are say low value brand or some brand are mid value brand. So in that case, what would happen is that okay, you are saying that okay, this flag not in this, these flags from some other table, then that would work. But the moment you say that okay, you want to extract only specific brands which start with say in A or which ends with an A, then I don't understand how you could use not in there or how it could benefit you. I mean, you probably could use not in there, but how it could benefit would be would be something difficult for me to kind of justify unless I really look into the data because
Yeah.
we don't really relate the two like this.
Actually, what happened? The purpose of the analysis is to filter one database and analyze that particular database, and that filter is some brands. So,
Okay.
what I did, I select percentage,
Okay,
then
okay.
brand
So
name
you're
percentage.
saying it doesn't really matter whether the brand name has A somewhere or E somewhere. You're not. You're
Yeah.
saying basically that you wanted to say, for example, we got set of brands like say Puma, Nike, Adidas, and
Hmm.
Reebok, right? Four
Yeah, means
brands,
I
right?
like percentage Nike percentage, and what he
Yeah.
did, he just put one flag for that. Say percentage Nike percentage is one, and then he used that particular flag
Yeah,
for
exactly. There. Yeah, I
other
got it.
analysis.
I see what you're saying now because you see, you're not doing, because I mean, the idea is that here in this case, if you have say four brands, Puma, Nike, Adidas, and Reebok, right, and you want to
Hmm.
filter out all the Puma branded products, right?
Hmm. Hmm.
So in that case, you're not, you don't really care whether Puma is part of it character string because Puma is the whole string that you're trying to compare. So there,
Yeah,
you
yeah,
see,
right.
if you want, you can easily create a flag and then you can write a not in query and you can get that easily. You don't have to do a not
Yeah.
like and you don't have to get into complication of whether not like construct or like construct is pattern has been created properly or not. You see, a lot of people are little scared of using like and not like because just because of these patterns that you have to create. Because
Mm-hmm.
if the pattern is not accurate, or say for example, in your in one of the say for example, you got a lot of SQs, a lot of product units, and in one
Mm-hmm.
of the product units, it was Puma shoes written instead of being written as Puma, it was written Puma shoes or something like that. So in
Mm-hmm.
that case, it becomes even more difficult. So in that case, it becomes easier to create a flag for Puma and then do a not in query and then do it.
Yeah,
Because
okay.
here we're not saying that Puma should be part of a string within another string. That's where real use of like and not like comes into the picture.
Mm-hmm.
Here you are comparing against the whole string, which is whole string Puma, whole string Nike, whole string the complete brand names.
It is easier
So
to use flag, right? Means one, two,
right,
something like
in
that.
that case, it will be easier. There will be less chances of human error because you see to create
Mm-hmm.
these patterns, right, and then to understand whether the pattern has been created properly, has the pattern taken care of all the permutation combinations possible,
Mm-hmm.
can be little difficult at times,
Okay.
especially if it is a complicated text value. So normally what happens is we normally recommend if the text values are complete. I mean, in the sense you are doing an exact match, right? So then there is no point using like or not like unless you're doing a pattern matching.
Yeah, yeah.
Yeah. All right.
Okay, okay, thanks.
Thank you. So list the students with an A as the second letter in their names, which is what we just okay. And now, in fact, now what we just did is these students who do not have A as the second letter. So if I run this, sorry, not in here. It should be not like. So it will be students who do not have A as the second letter, right? So that's how it works. All right, guys, I've taken 45 minutes, almost 45 minutes already. 2:30 is the. I wanted more queries, but no worries. We'll have more SQL parts in the coming weekends. So, guys, thanks a lot for joining in today. Should you have any more questions, you can ask me right now. I will wait for another 2 minutes for your questions, or else I'll just quickly recap all the topics that we have done today. So today we basically discussed about how do we handle different type of data values in SQL using different operators. Say, for example, we discussed about handling numbers. How do we handle without any quotes, text or character with pair or double quotes or single quotes, with date, with a pair of hash, with boolean yes, no, and then we had also discussed about the fact that we do not put any special character before the field name itself. We just put the special characters before the values, depending on the type of the characters. Then we had discussed about various different small SQL examples, starting with the first question, and then we had discussed about date. How do we handle date values, boolean values, and then we had discussed about distinct clause as well. We had discussed about variety of different functions that we can use in SQL. And we had also discussed the fact that there would be some functions like date which do not accept any arguments, right? So that also we discussed, and then we had discussed about how do we create a column label in SQL with an as operator. We had discussed about very important topic here, in and not in. In to find intersection between two different sets of tables, and not in to find difference between two different set of tables. And then we just discussed about like operator, which is to find pattern matching pattern matching with text values. So that's what we have discussed in today's seminar. In the next coming session, in the next coming part of SQL, I'm going to discuss about some more advanced topics of SQL. Some of the more advanced topics of SQL could be some more advanced functions, grouping and sorting data in SQL, working with text functions, very important, and then also joining variety of different joins and how do you handle data in joins. All right. Thank you, guys. Do not forget, if you wish, you can view the recording of this session on our YouTube channel. I'm going to write my channel on our on the chat window here. Plus, if you want to see, yes, last weekend seminar that also you can see on our YouTube channel. Our YouTube channel is youtube.com/ivproschool. Also, should you have any questions, you can about today's sessions or any questions about SQL, please feel free to reach out to us at info@ivproschool.com. All right, guys. Any other questions? Any questions from anyone? Again, the recording of today's session would be uploaded within 10 days, in the next 10 working days, on our YouTube channel. The recording of the last webinar is already up and running on our YouTube channel. So go ahead and subscribe to our YouTube channel for more such tutorials on analytics concepts. Thank you, everyone. It was nice talking to everyone. Thank you.